Hello, it's so great to be here presenting Open Source Gen AI and ML Summit 2025 Europe um, in collaboration with the Linux Foundation. I'm presenting to you today the research paper that I have published and another I'm working on currently under the title Emotion Estimation for Social Robotics. Summer Attrah, contributor, open source contributor to Google, and doing some independent AI research in the enterprise ML exploring, and under this hashtag. Some of my research I did as part of studying my master's degree in engineering systems at Han University of Applied Sciences in the Netherlands, Arnhem. And currently I'm job searching. And you can find me on my social media and portfolio for further projects. So emotion estimation can be done by having information from so many sources in the human that we might be missing in our everyday life. Some of these sources of information are the facial expressions, the body posture, text, sentiment analysis that is well known in natural language processing, and voice tone besides other from the audio. Now, estimating the emotion for the robot or for the artificial intelligence system help the humanoid robot to improve its behavior towards the human, understand what it's doing and how the human is accepting or rejecting the actions and what is happening in the environment around them, and help them to improve their behavior and help the human further in so many jobs and functionalities such as working in elderly care and patient care mainly. And there are other functionalities that might be in the future for safety and health, also integrated to the workflow. Now, in a more technical point of view, the emotion estimation system works as a feedback mechanism for the robot to help it understand the activities that it's being engaged in and the interactions that it's having from the humanoid robot and the human. And these interactions, having the emotion understanding and awareness will help it improve a lot, and it get added besides other functionalities that the robot is already working on, and maybe depending on some informations and commands that comes from the human, and further policies and pre-defined rules. And the most notable companies working on integrating emotion estimation to their robots are Hansen Robotics and Engineered Arts, besides others building their robots and systems. Starting with the emotion estimation and how to understand it in a more detail, could be from vision, such as facial expression and body posture, text as sentiment analysis, audio for speech recognition and voice tone, and there are medical signals that are specialized in the medicine application and patient care mainly. The understandable format for these models for the artificial intelligence or the robots, change it into other types, such as the landmark vectors and blend shapes for the vision, which interpret the photos as matrices and arrays of numbers, and understand the video frames as a sequence of arrays of numbers as a process that is well known in computer vision. Embeddings for the text and audio spectrum besides other representations for other types. The emotion estimation application mainly focus on understanding the emotion as categories and other presentations. The categories mainly as happy, sad, angry, surprise under the Ekman model, which includes 7 emotions. And there are others models. That is the compound emotions, including the happy, surprised, and maybe sadly angry, which represent feelings that we do have in our daily life, and it does help the robot to understand the human better, but it's more complex and more computationally expensive, and there are other considerations to be taken when working with other types of labels and descriptions for the images and video frames. Special emotions such as confused or overwhelmed or overjoyed or other types that also can be used. The other metrics that types of labels maybe to be used besides the categories are the action units, valence arousal, and so many others that can all be mentioned in the research paper and could be checked there as defined. Now, the artificial intelligence applications that are built for emotion estimation have few types. Generative AI for emotion estimation, which help the robot to express emotions and include sentiment in its reactions, adding more warmth to the text, maybe to the context, and have effects included. That get generated by chatbots or generative adversarial networks beside the transformer-based LLMs. But it's not the main part of our study. The analytical AI, which is we are focusing on here, is including the applications of classification, object detection, and segmentation, besides others, have the different types as maybe a historical timeline, starting from traditional AI and latest and the current technology being focused on as the transformers. The transformers is the most advanced and capable, but it's also more focused on generalization and understanding of a breadth of knowledge, not so much maybe helpful in a specific application if it's not specifically designed for it. Using pre-trained models is difficult to deliver a high performance, and as will be discussed later in the presentation. Our application that we are presenting mainly is based on the RNN type of the RNN, which is the LSTM, to deliver a classification functionality for blend shapes. And later we'll be detailing this application. And the computer vision for emotion estimation for facial expression works in mainly 3 steps: the face detection, feature extraction, and expression classification. MediaPipe library presenting a solution for edge devices to deliver the functions of face detection and feature extraction in a short and compact code using a highly efficient models that are built inside the library and functions in so many options and could be tuned by using the settings provided. And in our research, we are researching delivering expression classification models. Now, from this semantic, can see the a human being detected using a video camera, and the face detection happens using the media pipe library and the landmark estimation too. This is a notation generated by media pipe library, shows the more than 470 landmarks drawn on the face. A subgroup of them is used to generate the blend shapes, the feature extraction operation to have 52 blend shapes. 50 blend shapes are shown here in this table. And these blend shapes get inputted into AI model to deliver the labels and the classification of the uh, facial expression started in the detected in the human face. The now AI model is presented in more detail later. The blend shapes specifically that get extracted are approximate semantic parameterizations and a linear model that is generated by MediaPipe, including 52 floating numbers ranging between 0 and 1. And for this image right here, for a professional in the office outfit, detecting the blend shapes are in the histogram, shows that only the blend shapes for the mouth closed and tips of the mouth are raised, and besides the eye blend shapes are activated, and so many others are not activated here because they are not relevant for the facial expression that is now on the face. For example, if this lady turned into having an angry facial expression, a different set of blend shapes will be activated, and maybe the active one currently will not show any scores. The data used for building the research paper that we worked on is the FER 2013 challenge dataset. The dataset was processed heavily by augmentation and filtering and cleaning until delivered a 52 K of blend shaped vectors that correspond to images of the dataset, categorized in only 3 categories, which is the happy, sad, and all the other 7 categories originally are included in a single one called unknown. Further work will be delivered on the effect-while-2 dataset, which has so many other labels, categories, and training examples. The research paper that we have published previously, emotion estimation from video footage with LSTM, is shown here. I worked on it mainly when I was a student at Han University of Applied Sciences. And it's made of 4 layers of LSTM and a 5th one for classification, a fully connected layer. And it delivers 71% accuracy and 62% F1 score. In addition to good results on the confusion metrics as shown, there is a big imbalance in the dataset classes. So it obviously have the unknown class as the main detectable class, but it also does detect the happy and sad. And there is some type of oscillation between the happy and sad emotions and which one to be more detected. And that could be fine-tuned in the model and further improved in other approaches. Now, another ablation study that was researched in the as part of that work is feature pruning. We call it that because it's based on selecting the more interesting blend shapes from the dataset. So for the FER 2013 dataset, visualized here in this scatter plot, there are a group of blend shapes that are have a wide range of values, in contrast to others that are only settled on the bottom of the scatter plot and doesn't have values for all the training examples of the dataset. These are the limited in range blend shapes get deleted. And there is a statistical method described here for the deletion or the keeping of the blend shapes. This process ended up with 27 included blend shapes in the dataset, which cut down the computation resources used. And that improves the possibility to use the model and more efficiently. Now, after delivering that model using the LSTM layers, started working with LLMs as they are the more developed model of artificial intelligence and showing great results and possibilities for further improvement and delivering higher performance. Now, considering all the limitations in the market and the limitations in resources available to the research, couldn't develop the customized transformer for the motion estimation or use a large size LLMs that are commercially available today. So working with a 1 billion transformer or LLM from the providers there on the market today, have few models, and that had me working with text only instead of vision. And of course, working with text will improve the explainability of the process and improve the understanding for the capabilities of the LLM, besides delivering probably better results, including only the blend shapes instead of the full image. So it has two sides of qualities. And this process started with working with Hugging Face in the beginning, and a few of the models here were experimented with. The Liquid AI model delivered quality results almost similar to the Google Gamma, and they almost settled at the same level of understanding for the blend shapes and for the required. But since the Liquid AI research indicates that it's built for dynamic systems instead of emotion estimation and image classification, so continuing with Gamma, and it's the model that is currently being experimented with instead of the other three that didn't really show the same level of understanding for the application required. And using the Gemini API also showed a much better improved result. And working with JAX and Gamma is for future experiments and further improvement for the model. Now, to have more control on the process and improving the LLM and experimenting how to have the smaller model for delivering high motion estimation while keeping the process understandable using DSPy library, enable using different types of prompts, including RAG in the process and the pipeline, and maybe later we'll be fine-tuning Gamma to be more capable in emotion estimation. Beside that, currently the work is on the 1 billion model. So including the work on a larger model with more models in the future, possibly, or having all the models on a single large LLM to be delivering on different emotion estimation models instead of single one. That also possible, but limited resources. Once again, is the block here. And this is a demonstration for the functionality of the LSTM model. It shows the face when it smiles, the here and the command line. The emotion is printed out, unknown and sad in correspondence to the emotion shown, and unknown for any other emotion that other than happy and sad, with other, of course, information being printed here. Further details about the research paper of the LSTM is already published, and the LLM is a work in progress besides another research that might be published in the future. Now, these are the references, and thank you so much for listening. Please do contact me for any questions, suggestions, or comments. This is my contact information, and thanks a lot to Linux Foundation and all of you watching this presentation.